This is where we were in our last video. We spoke about the gradient of a scalar field, and this is the formula here. Alright? Now we want to talk about the divergence, well, of a vector field. Alright? Now, just like how the gradient acted on a scalar field to give a vector, what will happen here is that the divergence, sometimes we call it div, the divergent acts on a vector field to give a scalar. Alright? Now, the divergence here or the div is written as nabla dot a. Now, nabla is equal to partial derivative of something by partial derivative of x in the I direction plus partial derivative of something else, whatever it is, by partial derivative of y in the j direction plus partial derivative of something else, by partial derivative of z in the k direction, right? Now, nabla can't stand by itself. It's waiting on something to act on. Just like when you say sine or cosine or tangent. If you say the sine, then I would ask you the sine of what? Because you have to have an angle and you find the sine of the angle. So if you say the divergence, so divergence of what? Well, it's divergence of a vector. So let's say vector A. Let me just draw a little line above it. If I was typing and could bold it, it would be in bold, right? I'll draw a little line above it. The vector A is A of x in the direction I plus AY in the direction j. That's lowercase. The name of the vector I put as uppercase. And then AZ in the k direction. Alright. AX is a function, right? It could be x squared, it could be 3x plus 2y or 3x, 3x y squared, whatever it is. Right? Now, this is a dot product of del or nabla, what they call it, and the vector. Now remember, when you're doing the dot product, you multiply the coefficients of I in both cases. So what you have is a partial by partial x of ax. With the dot product, you have no direction, so you drop off the i's and so on, right? You have no directions in the answer. It's going to be a scalar. Here, coefficient of j times coefficient of j. So it's a partial by partial y of ay plus, and then here, coefficient of k by coefficient of k. So it's partial by partial z of a z, right? So whatever ax is, you differentiate with respect to x. Whatever ay is, you differentiate with respect to y, and whatever az is, you differentiate it with respect to z. So that's a formula for the divergence. It acts on a vector to produce a scalar, and it is the dot product of the nabla, upside down triangle with the point sticking into the ground, right? So that's the upside down triangle dot the vector. Remember, both of them really are vectors, but you find the dot product of two vectors, so you get a scalar. And in this case, we have the divergence. Now, in later videos, we'll look at some examples, work out some examples of this thing. Alright, so I'll see you in the next video.